if you do not have enough room, if you do need a larger copy, I printed 10, but make sure you really need that. Otherwise, you can write on a separate sheet of paper if you just need more room to write, okay? But I did print normal size papers for just in case people have hard time seeing. All right, let's do this. So your test is tomorrow. So let's look at the first 5 right now. So our first question says, the first person to propose the concept of indivisible particles or atomos was who? Yep, Democritus. Good. All right. Number 2, we're going to kind of throw this one out, but just so you know, because we're not testing you over it, but the 2 that he had 5 postulates, and 2 of them ended up being wrong. One was that he said they're indivisible, because now we know there's protons, neutrons, electrons, so they are definitely divisible. There's stuff smaller. And then he also said that compounds go together are the same for everybody, right? And he said all atoms are identical. That's what he said. All atoms are identical, and we now know there's isotopes, there's ions, right? So they're not all identical, okay? So those were the 2 that weren't right, but don't worry about writing that down. You guys are good. All right, number 3, be careful with this one. Please note, when you get to this, oh, never mind. That's number 4. Number 3, not the picture. Ernest Rutherford used the gold foil experiment to learn about the atom in 1911. Describe his discovery. So this was the gold foil. So he sent little alpha particles through, and what happened to them? They bounced off something, right? Don't worry about that one yet. We're not on that one. Alpha particles repelled something. So what did he discover? Ernest Rutherford discovered the what? Not electrons. The other one. Protons. So where are the protons at? The nucleus. So he discovered the nucleus. His is the nuclear model. Okay? It's not related to this picture. I know it looks very misleading. I think I messed up my spacing on the question. So alpha particles, which were positive, repelled something. They repelled the nucleus. So they bounced away and they weren't going straight through anymore. Okay, J.J. Thomson is the other one. That's what the picture is related to. He used this device that's above, that's a cathode ray tube, to demonstrate the behavior of cathode rays. All right, so people still miss this question on the quiz. Okay, so I want to make sure we all get it. So when you go to take the test tomorrow, it is not this picture. It is not that picture. Look carefully at it, because the picture tomorrow has the positive at the top and the negative at the bottom. This one right here, what do we have? We have negative at the top. We have positive at the bottom. So those particles, looking at the direction of this, what can you tell me those particles were? Negative, because they're doing what? Repelling the negative and attracting to the positive. Okay? So they were negative. So you can put electrons if you want. Negative, because they repel the negative plate. So when you see that question and you're asked to draw it, what direction do you need to go towards? The positive. So figure out which plate we're giving you. Most likely it's switch. Hint, hint. You're going to be doing opposite of what this picture is showing in terms of like the drawing of it, okay? It's still going towards the positive. I just wanted to make sure you guys don't make a mistake, all right? You guys got this. Negative plate, yeah, sorry. There you go. All right, number 5. Niels Bohr described the orbital model or the planetary model, okay, of electrons and stated that they moved in circles or orbits around the nucleus. And just add in here at energy levels. So his was very circles, all those circles inside of each other, right? All right, are there any questions on numbers 1 through 5 so far? We're all good?